In this video, I am going to start straight lines. So now the straight lines are very important in a common life in any applications. Straight line equations or linear equations. So we have to deal with so many straight lines. So we have to be familiar with how to deal with a straight line. So I'm going to begin with an important parameter for straight line, that is a slope. So what is a slope? Generally, I can start with the general expression of slope. Slope of a line. Now consider that I draw a line. I will consider a 2D axis, a Cartesian coordinate system. This is x-axis and y-axis. And if I try to draw a line, for convenience, let me draw a line which touches the positive x-axis. Let me change the ink. Straight line. So I'm not passing it through origin because that will make it more simpler. So if you know that if I want to measure the angle from x-axis, from the positive x-axis, no, I mean any x-axis, there are two ways you can measure the angle from the positive x-axis. That is, I can go in this way. So this is the angle. Again, let me change the ink. So this is a straight line. And let me use it. So if I go, no. So this is a straight line, and if I want to measure the angle, how I am going to do it? So there are two ways to measure the angle. I can go like this, and also similarly I can come like this. So always there are two ways to measure the angle. I can consider, if I consider this as theta, for example this angle is theta, then if I can write this as 180 minus theta. So because this is a supplementary angle, that you know that it is a linear pair, it is, so the sum of angles is 180. So now I am going to start from here, this angle. Now my concern will be, I will define the slope of the line as slope of a line m. I will denote slope of the line as m, and which is equal to tan theta. So now I am going to say one more thing. You know that radians notation, if I use pi, that implies 180 degree, pi by 2 is 90. So this let it be there, and pi by 4 is 45 for just for convenience. So pi by 6 is 30 degree. So now the slope of a line, I am defining it as tan theta. But now you may ask the question, but if theta is 90 degree, for example, if I take theta equal to 90 degree, that is what? That is y-axis, right? This is y-axis, or any line parallel to y-axis will have theta is equal to 90 degree. So you know that from the trigonometry, tan 90 is undefined, right? Tan 90 is infinity or not defined. Tan 90 not defined, right? So I can say that the slope, this formula is valid only when for, I can write for theta not equal to 90 degree, because we want always finite value. In many mathematics we want a finite value, we don't want to go to indefinite value like infinity. Even in limits we saw there is form that if you go by infinity form, infinity by infinity or 0 by 0 form, you will try to solve in a different way. Similarly here also, we don't need that infinity term to come here. So we want always to work in a domain where everything works, everything is defined. So I will eliminate this theta not equal to 90, we will use this formula, so tan theta. And also, as you know that I have from the calculus, I can know that m is equal to differentiation of y with respect to x. I can write slope is the derivative of y with respect to x, especially if you consider straight line. Consider straight line will be of form y is equal to mx plus c. So now if I want to take derivative dy by dx, you know that derivative of mx is x and c is a constant, so derivative is m. So again I will end up m is equal to tan theta. So as you know that the slope of a straight line is a constant, I can say that it is a constant. But also I want to derive specifically few results, because why this derivation is important is you need to know how the things come, because it will be very useful. So now I have two conditions. So one is when, and also similarly I told that slope of y-axis is not defined. So what is the slope of x-axis? Slope of x-axis is tan 0 degrees, that is 0. The slope is 0. So any line parallel to x-axis or x-axis itself, slope is 0. So the first condition is that many cases we don't know the angle, right? Because angle, we don't know how to compute the angle, we don't know how to calculate the angle, but we know the coordinates of it. Since it is a Cartesian coordinate system, we know the coordinates, right? We will know the coordinates of a point. We are always know the coordinates of the points. So I will take 2 points. So let this be A and x1 comma y1, and this point be B, x2 comma y2. So this I am representing in this way. So I want to compute the slope given the 2 points in a line. So we know the 2 points of line, and also I want to compute not only line, but this is a general formula which applies to any curve. So let me check how. For example, I will begin by dropping the perpendicular. I will change the color. So for example, now I am dropping a perpendicular. This is x-axis and this is y-axis. Similarly, I am dropping a perpendicular, and I know that this angle is theta. So now if I drop both perpendiculars and if I join this, you can even visually you can see that these angles are equal. Why? There is a reason why these two are equal. I'm going to come to that. Because these are parallel lines. This line is parallel to x-axis. So the angles are equal. Corresponding angles are equal. These form corresponding angles. Right? So these two are equal. Also you can think in a way that this is a big triangle. Inside that big triangle there are two parallel lines. So they will again form the same corresponding angles. So these both will be equal. So now I am going to use the result now. Let me check how, because we know that since this point is x1, so this distance is nothing but x1, and this distance is x1, and this distance from origin is x2. So what is this one now? Now I want to find how to compute the theta. You have to compute the tan theta. To find the slope, we need tan theta. So tan theta is, let me name for example, I will name it as this is already A, and I can name it as point C. So we have to tan theta, we have to find tan theta is equal to uh, opposite by adjacent. So if you, it is better to, once you just, I have made a video related to trigonometric formulas once, class 10 trigonometry formulas in everything revision. Once you can check out that video. So this one, opposite by adjacent. I hope you are familiar with the tan theta definition. So what is opposite? Opposite nothing but BC. So similarly, I can write this as y1, and till here this point is y2. So now what will be C? Now you know that C is nothing but the difference between these two, right? You can observe y2 minus y1, because y2 is up till here and y1 is only till here. We need only this point. Similarly, what is this one? This one is x2 minus x1. So tan theta is equal to BC by AC. So which is equal to y2 minus y1 by x2 minus x1. So I think this is a general expression. Now I am not going beyond this. Even if you take theta is equal to 180 minus theta, then it will work out. Why? There are several reasons. I am not going to go there, but you have to know that even if I take even when angle is not a complementary angle, that is angle even if theta is not less than 90 degree, still my result is valid. So this is what I am not going you. I am leaving it up to you because that is not needed now. Similarly, I am going to now there are two cases. Now I have derived the formula slope in the form of coordinates. So we know in the form of angle, we have defined it as tan theta. So now we know in the form of coordinates. Now the straight lines are going to be two different types, right? For example, if I want to deal with two different straight lines, they are, if I will consider two cases, when straight lines, case 1, when straight lines are parallel to each other, I will take a system, I will take two straight lines. For example, let me draw a straight line and let this be another straight line. They are parallel to each other. So they are parallel to each other, their angle are theta. Let it be theta 1 and theta 2. So this is very clear, right? Because if I take theta 1 and theta 2, you can clearly observe that since these two are parallel, and also this line which is x-axis is intersecting, again this become a corresponding angles, or this again become a pair of angles which are equal. So this inclination, I can say that this are equal, these angles. So theta 1 is equal to theta 2. So I can say that tan theta 1. Similarly, I can say that if both angles are equal, then tangent of their angles are also equal. So with this way, I can conclude that slope of lines are equal. Case 1, when parallel lines, slope condition. So M1 is equal to M2 is a condition when two lines are parallel. So equivalently, when I can say that there are two lines are parallel. So when there is a way to say when two lines are parallel, right? How I can say it? I can say that M1 is equal to M2. So similarly, I will come into this, for example, you know that how a straight line is represented, right? For example, consider a linear equation, not x1, ax plus by plus c is equal to 0 represents a straight line. But there are two variables in it. Why I am taking two variables? Let me give a clarity now. We know that this is a linear equation in two variables, and also for example, I'll let me take it as a1, b1 and c1. One line equation is a1x and other line equation is a2x plus b2y plus c2 is equal to 0. So in this manner I am going to prove you that how we can derive the equation of a straight line if we know the equation of one straight line. If other condition, if we know that it is parallel, then we can derive the equation of other straight line very easily. How? Consider this linear equation. This is the linear equation in two variables. You know that if you plot it will give a straight line because these two variables are there. So now I am going to start with a condition. I am going to say that you know that slope of 1 is equal to slope of 2. I have defined the slope in that way also, right? Y is equal to, slope is equal to dy by dx. So differentiation. I hope you will be aware of differentiation. At least a basic differentiation. Or let me do this later. But let it be tasked. Those who are aware of differentiation, then you can derive such an expression. For example, I am not revealing it. You can just try doing it. I will do in some other video. I will continue with case 2. Perpendicular lines. Now this is little tricky and also interesting case. How we will know from the slopes that two lines are perpendicular? Consider a line like this, also another line which is perpendicular. So this is obviously more than 90-degree angle. This is theta 1, let it be this theta 2. So now how I am going to say that these two lines are perpendicular, line 1 and line 2. Let me name this x and y. So this is my chart. Now what can I do? We know that this is a first of all I want to stress that this is a triangle. This is a right triangle. We know one angle here. Since this is a linear pair, opposite angles are equal. I can say that. So if 90, this also 90. And also using exterior angle property, I can say that theta 1 is equal to 90 plus theta 2. So now we got the relation between theta 1 and theta 2. If the slope of the first line, let me name it line 1 and this should be line 2 for convenience. Because I took here theta 1, so it should be 1. We should not get confused. So if I take tan theta 1 m1. Similarly, slope of second line m2 is equal to tan of So for example, if I want to take theta 2 in terms of theta 1, so theta 2 is because we know the relation between 90-degree angle, right? So theta 2 is equal to theta 1 minus 90, or let me take m2 is equal to tan theta 2 and m1 is equal to tan of 90 plus theta 2. So if I take this, you know the tan expression, right? Tan A. I can write tan A plus tan B divided by 1 minus tan A into tan B. Or in case if you are familiar, because this is a 90-degree angle, I can write directly. Only it will change to cot. So it will change to a cot, right? So I can write that minus cot theta, because it is in a second, this is in second coordinate, second quadrant. So I can say this is tan theta is negative in that quadrant, so I can write minus cot theta 2. So you can try using this formula also, this will work out, but I am not doing it now. Minus cot theta 2. So if I take this way, I am going to do it in, so this condition is, now we know that slope m1 and m2 are, m1 is minus cot theta 2 and m2 is tan theta 2. So now from trigonometry, you might be aware that, now I am going to continue here this part. From trigonometry you might be aware that what is the relation between tan and cot. Tan and cot, what is the relation between tan theta and cot theta? So we know that tan theta is equal to 1 by cot theta, or vice versa. So what you will get, if I multiply tan theta and cot theta, it will be 1. So tan theta into cot theta, now m1 into m2, if I do it, m1 into m2 is equal to tan theta 2 into minus cot theta 2. So this is nothing but minus 1, because minus sign is there. So m1 into m2 is equal to minus 1. So this is a condition which, if the slopes are, multiplication of the slopes is minus 1, or I can say m2 is equal to minus 1 by m1, or m1 is equal to minus 1 by m2, then these are perpendicular lines. Condition for perpendicular lines. How do we know? Because you see the slope is how much powerful. We don't know anything about the lines, but if we know the slopes, then we can say whether lines are parallel to each other or lines are perpendicular to each other. And we can also say so many things, and we will look into those things slowly. And I'll continue the rest in the next video. Thank you.